Hello everyone, so welcome back to ECD lab experiment number 6, that is to write Verilog code for D flip-flop with reset and simulate with test bench synthesis implement on PID. So let's check what actually the D flip-flop is. So D flip-flop is a basic single bit memory cell which generally used to store a single bit. So let us assume where D is this is the block diagram of your D flip-flop. It has the input is D, the clock, reset, and the output is Q. So how it performs? It's simply your input D goes to your output. It means Q equals to D. But the condition is when there is a rising edge of the clock. When there is rising edge of the clock, you can say your input goes to output. That is that much of simple. So it means here you can write the condition if clock is rising edge, your Q becomes D. Else if clock is not rising edge, then Q should be hold its previous state. Q should be hold its previous state. Now when there is a reset is 1, so your output Q equals to 0. When the reset is 0, it will work with respect to the clock. So if you are looking for the truth table, you are finding when the clock is not rising edge, whatever at reset, whatever at your D, that means input, your output should be previous state. If the clock is rising and the reset is 1, the output is 0, it does not affect on your input. If the clock is rising edge, reset is 0, it depends on your input. If your input is 0, your output is 0. If your input is 1, the output is 1. That is that much of simple working of D flip-flop. Now here we are looking for the design. So how we can design using Verilog. So let's check using Verilog. So as already we have taken that the experiment number 4 and 5, and here we are looking for experiment number 6. So to write the Verilog code, here we need that Verilog file, and for that we have to create the new source. So right click here, new source, choose your Verilog module. Let's take the name is D_FF, that is D flip-flop. Next, what the inputs are there? So D is first input, the clock is second input, and the reset is third input, as all are single bit, and the output is Q. So change the direction, again it is single bit. Next, finish. So default template is here for D flip-flop. Again it works sequentially because with respect to your clock the output will change. That means if the clock is rising edge, your input goes to output, else it should be hold previous state. That's why here we use that if else statements. So again we have to use that procedural block, that is always at the rate. Now when this block should be executed, it should be executed when there is a rising edge of the clock, and for that we use the keyword is pause edge. Pause edge of what? Pause edge of your clock. That is a sensitivity list. It means whenever there is a rising edge of the clock, this block will execute, else not. So what the first condition is? First condition is if reset is 1. So what my output should be? My output should be Q equals to 1 tick B 0. Else Q equals to D. That much of simple. Q equals to D. So it is simple program of your D flip-flop, nothing else with reset. What here, when we have written that the procedural block, always your output should be registered data type because it should hold the previous data if the clock is not rising edge. So it is simple as, so save as. We are having 3 different files. Now we are going to synthesize D flip-flop. So we have to set as top model. Now double click on synthesize. It is running. If there is any error it shows, else it shows that green tick. Yes, it is done. So synthesis is done. You can check it RTL schematic. This D flip-flop block diagrams, what inside it, that we are checking here. So you will find that there is a D flip-flop inside it. So D is connected with D, C is nothing but clock. You find here that the triangle with the line, so it is positive edge. If there is a bubble, that is of negative edge, reset, and there is output. So it is simply of your RT schematic. So in next video we will checking their test bench code. We will simulate it. Thank you.